This is Shubhangi Prabhakar, and I am making this video as part of a project for the course IFT 510 at Arizona State University under Professor Jim Helm. So in this project, I emulate an 8x8 Banyan network, and after that I do a 16x16 version of it. So to start off, a Banyan network is a non-blocking multi-stage interconnection network that is used in shared memory multiprocessor interconnection. So I've used Python to code this program. So first off, we import the random function, which will help us generate our random inputs. And this first function over here is to convert the random inputs into their binary formats, and these lines of code ensure that the inputs are, once they're converted into binary, they are exactly 3 digits, because we have 3 stages of the Banyan network, because it's an 8x8 delta network. So first let's go to the Banyan part of the program, the batch switch. So here we create a list for the input, and we assign the length 8 since we have 8 inputs to take. And using this random function, we generate exactly 8 random digits from 0 to 7, and we store it in the input list called INP. And input.sort, this dot sort function sorts the input list, and we can see the sorted input list here. This is the randomly generated list, and this is the sorted input list. Okay, now let's go to each stage of the Banyan network. So switch A defines the first stage of the network. So switch A takes 2 inputs, one is the input and one is the destination. So destination is the routing number. In real life, the routing number is accepted, and for every stage that the routing number is, the information is passed on, the routing number is used to read the first digit of the routing number. And once the first digit of the routing number is read, the first digit is discarded and the rest is passed on. So the first digit of the routing number decides the path that the information takes. So here, instead of using a left shift or anything like that, I have just mentioned which position exactly has to be read to decide the next path. So here, destination, the first digit of the destination is read, and if it is 0, the path goes from A1 to B1, and if it is 1, the path goes from A1 to B3. And every if loop in this stage does this, and respectively at every stage the same thing is carried on. And finally, every function returns the final path. I have named it P2, P3, P4. So and this defines how the inputs will be fed into the first stage, which is the A, which I've named as A1, A2, A3. So this start here represents how the information will be fed into the first stage. And this for loop finally reads the output, reads the input, converts it into its binary format, takes it through each of these defined functions, and then finally prints the path from source to destination and which path it takes. Okay, so let's run the results now. So this is the randomly generated input, and here we can see that the inputs are sorted, and here we can see how exactly the information is entering the first stage of the batch or Banyan network. So this is that. And so suppose so this is the output. So we can see that suppose CPU 3 wants to send a memory request to a memory module 3, then it will use the binary equivalent of the number 3, which is 011, and here you can see that it successfully reaches the memory module 3, and it does so by passing through A4, B2 and C2. Similarly, for if CPU 6 has to send a memory request to a memory module 6, then its binary equivalent, which is 110, is used to send information through the path A3, B3, C4 and finally to 6. So this is about 8x8 delta network, and I've scaled the same thing into a 16x16 delta network. The only thing here is we have so what changes from an 8x8 to 16x16 delta network is that we have 4 stages of fabric. We have 4 stages of Banyan Badger network, and so we need exactly 4 digits in our when our input is converted into its binary format. So here we are ensuring the same. We are ensuring that each digit, when converted into its binary format, is exactly 4 digits. And these switches are pretty much the same. But obviously we have 8 steps here. That is for 8 batcher switches for every stage in the Banyan batcher network. So switch A, B, C and D are defined, and here we are using the random generator to generate integers from 0 to 15, and we are generating 16 integers since our network is a 16x16 network. And okay, let's see. Here we have an additional path. Because we had an additional stage. So let's run the results. So this is the randomly generated input consisting of 16 digits. This is the sorted input list, and this line here tells us exactly what is entering the first batch of the network, first stage of the network, I'm sorry. And so we can see path from 0 to 0 reaches 0 successfully through A1, B1, C1, D1. Here, for example, if CPU 7 has to send a memory request or an address to a memory module 7, then it uses its binary equivalent, which is 0111, a 4-digit equivalent, to send the information through A8, B7, C6, D4 and eventually the 7th memory module.